to evaluate this integral, we try to get rid of this fraction, because there is no quotient rule, there is no fraction rule for integral. Okay, since we have only one term on the top, we cannot separate into two. The only way it seems now, we have to make a substitution from which we can get rid of the fraction. And look at the bottom, 1 plus x cubed. What is the derivative of 1 plus x cubed? That's 3x squared, which is some constant multiple of the top. Okay, so the derivative of bottom is 3x squared. We don't have 3, but we can always multiply and divide by a number, because 3 cancel, so we did not change anything. So the top 3x squared is in fact the derivative of bottom, 1 plus x cubed. Derivative of 1 plus x cubed is 3x squared dx. Now we can use this formula, as you have seen, antiderivative of 1 over u du. The derivative of u is 1 with respect to u. The antiderivative of 1 over u du is natural log of absolute u plus c. Okay, we have exact same situation with this modification. So 1/3 stays outside. The top is the derivative of bottom, so the antiderivative of this fraction is natural log of bottom, 1 plus x cubed and plus some constant. Done. We got a quotient of two functions, and there is no quotient rule for integral, so somehow we need to get rid of this fraction, and for that we always make u substitution. And generally the inside function we say that's as u. Okay, in this case natural log of x, this one is u. If we think this is u, then this reads sine u, remains 1 over x dx, and that should be du. Okay, differential of u. Let's see, what is the derivative of natural log of x? Derivative of natural log of x is 1 over x. Okay, so here is bottom, so 1 over x, that's the derivative of u. And in fact differential of u du would be 1. If we think u is natural log of x, then the derivative in this case, in fact differential of u is 1 over x with respect to x dx. So sine u, the remaining 1 over x dx, 1 over x dx becomes du. So the whole integral is basically sine u, integral of sine u du. Okay, this is same as now sine u, and the remaining 1 over x dx, that's du. And we know the antiderivative of sine u, which is negative cosine u plus c, and our u is in fact natural log of x. So we can go in that way, or if you want to go through all these steps, then we assume let u be the inside function natural log of x. Okay, let me erase this over here. Now we want to convert this equation in terms of u. So we take the derivatives of with respect to x, then du over dx. So I'm right here, this is in terms of differentials, and derivative of natural log of x is 1 over x. Now isolate dx, so if you multiply x du, so dx is x du. With these substitutions, this question in fact becomes sine u over x, no information, and dx is x du. Now x says can be cancelled, then we have integral of sine u du, and antiderivative of sine u is negative cosine u plus c. Now back substitute the value of u. Done. Negative cosine u. U is natural log of x plus c. I showed you the alternative way, which would be just the short form of this. Okay, we have sine natural log of x over x dx. If we think this is u, this is sine u, and derivative of u, derivative of natural log of x is 1 over x dx. So 1 over x dx, that becomes du. Okay, so this question is now antiderivative of sine u du. So we would be in this step, and that's negative cosine u plus c, and negative cosine u. U is natural log of x plus c. We have a quotient, a fraction of two functions. There is no quotient rule, so we need to get rid of this quotient, and we have natural log of x quantity raised to 4. So we need to make a substitution here. Okay, the inside function is natural log of x. Let's say that's our u. Okay, this is our u. Okay, so let's write in this way: let u be natural log of x. Okay, and then we want to convert dx in terms of du. For that, we take the derivatives with respect to x. So du over dx, derivative of natural log of x is 1 over x. Then we get dx1 dx equals x du. Oh, we already isolated dx. Okay, then the integral now, integral means this question is, this is our u to the 4th over 4x, no information, just write 4x times dx. We just found dx to be x du. Okay, now we want to simplify this one. If you look at it closely, x on the top, x on the bottom cancel. Then we have u to the 4th du, and this 4 we can pull 4 outside, so that's 1/4, and u to the 4th du. Okay, 1/4 outside. Now antiderivative of u to the 4th, power rule, u 4 plus 1 5 over 5 plus c. Back substitute the value of u, that's natural log of x. We are done. So 4 times 5 20, so we can write 1 over 20 u to the 5th. U is natural log of x to the 5th, and plus c. Final. Okay, you can make educated guess. That reduces a couple of steps.